We've got to batch out a whole heap of serving trays similar to this one here. Because we've got to do 12 of these, we are going to use the CNC, but before we can jump on the tools, we've got to 3D model them.
We are going to be doing this in Fusion 360 because that's what I'm familiar with. The benefit of Fusion 360 is that it's both a CAM and a CAD software. If you're not sure of the difference, check out the description. I'll have a playlist of everything CNC where you can catch up to speed on that sort of thing. But we are going to jump straight in. So we're going to be designing this tray here. It is a simple tray. We're going to show you two ways to do it. The first one will be a bit more in-depth and complicated. The second way, simple. Easiest thing you'll ever do. Maybe not as simple as breathing, but it is relatively easy. We're going to be talking through what bits to use, when to use them, how to set them up as well. So let's just dive straight in and jump on Fusion. Okay, so you're in Fusion and you've got a new workspace open. What you want to do is go up here to create a sketch. I'm going to be going through this relatively quickly if you're not familiar with the basics of Fusion 360. If you want to know more about it, let me know in the comments below and I may do a series on the software itself. Okay, so new sketch up here and we are going to go on the bottom plane there. So we're drawing from the top, circle. We're creating a circle here and we're going to make this a 300 millimeters. So that's our circle there. Now the next bit of important information is because we're making this to house a ramekin, let me grab a ramekin. An organized individual would have had that ramekin handy, but that's not me, so apologies. Ramekin sits inside said groove. You need to make sure you know what ramekin you're using and how big that ramekin is. So I'm just going to grab measuring tape, measure that one up. I'm in an office, so I'm going to use a ruler, but measuring tape works just as well. So we are roughly 90 millimeters. So we're going to make our size 90 millimeters. That is a relatively standard size. So we're going to hit C for circle, and we're going to make that 90 millimeters. If you don't want to use your keyboard, you can use these up here, but I highly recommend you learn the shortcuts. It speeds up the workflow astronomically. And now we're going to throw in some offsets. So basically, we've got our inside dimension here and our outside dimension. That's what we've got on the screen there. We need to offset that to give these upstands. So in our case, we're gonna go 10 millimeters. So up the top here, you've got this offset tool. So click on that, select your circle. We're gonna drag outwards of the center. We're gonna make that 10 millimeters. We're gonna do the same thing, but we're gonna drag inwards of the outside circle. So we're gonna need to make that minus 10 millimeters. That gives us our offsets there. Now, all we need to do is add our dividers. You can do 4, you can do 2, whatever works for you. I'm just going to mimic this and we're going to do the exact same thing. So you're going to put in a line. Now basically we need to put a cross in to then give us our offsets based off that line. So we're going to use what's called a construction line. So if you see, to work out where the actual thing on the screen was, because I use X, that's the shortcut for a construction line. But this line here, so the line type, we're going to make this a construction line. And then we're just going to drag outwards until we hit the edge. And we are going to do this, do the same thing in all 4 directions. Now you can see there, I'll zoom in for you. See how our lines we made earlier are solid and these are dotted lines? Those dotted lines just represent the fact that they can't be extruded. They can't be used within the model other than a reference line. So now we're going to push X again. Because see here, we're still selected as a construction. If I hit X on the keyboard, it then takes that away. Now when we use our offset tool, back up top, we're gonna offset off these 5 millimeters. If you didn't take off construction, that would be a construction line and you wouldn't be able to reference anything off that again. So we're gonna do the same thing here. We are gonna offset -5, and we're gonna do the same to all of the lines we just made. Okay, so effectively, that there is our sketch. Now this is where you can complicate it as much as you like or make it as easy as you like, depending on what you're trying to achieve. We can now extrude straight off that, or you can go ahead and you can make all of your fillets, so your rounds in your corners. But the reality is, when we cut this out, if I can get this bit out without cutting my fingers up.
One eternity later.
Got there. We're going to use a bowl and tray bit. That's what I know it as. I don't know if that's its technical name. According to Timbicon, it is a DC-318H bit. but bowl and tray bit. So effectively, this gets used for bowls and trays. Fancy that. But you can see that the corners are rounded and the edges are rounded. So naturally, when we set up the G-code based off this bit, it will automatically do all of that in the software itself. The only reason you would need to do it in the software currently is if you wanted to see what it's gonna look like. So you can take the time, it's gonna add a bit of work to your workflow, or you can just punch it out based on that. So in this case, we're just going off that because we just wanna show you how to actually achieve one of these bad boys. Okay, so we're gonna now click up Finish Sketch, and then you now have everything to work with. So we're gonna extrude this, extrude, So we wanna select it all. We're working with 20 mil thick timber. We're gonna make a 10 mil base and then 10 mil cutout. So from that, we're gonna extrude down 10 millimeters and up 10 millimeters. So minus 10, that gets us our solid base. So there is our base. Now, whoops, knocking stuff over left, right, and center here. So we want to turn that sketch back on so we can see it again. Now, hit E, extrude. So we're going to then pull up everything we want to be pulled up. So we're just going around and selecting all of the bits and pieces. And we're not, whoops, that one we don't want. I'm not doing a very good job of this. Okay, notice here, I'm just going to zoom in for your knowledge here. That's where that construction line is. I can't select either side of that line. That's what the construction line's for. It's just a reference point. Can't use it when you're actually modeling in. Okay, so we are then gonna pull this up 10 millimeters, and then we wanna make sure the operation is join over here. I believe that's the default. Might be different for everyone, but join is what you're wanting. And then we can turn off all of our sketches. Bang. Now, theoretically, we have a 20 mil high wall here, 10 mil step down, 10 mil step down, 10 mil step down there. Again, you could go through and throw a fillet on the inside to represent what you're actually gonna have, but not required. It's gonna naturally do it anyway. And there we have it. The tray is made. That is exactly what you need to then go ahead and cut one of these bad boys out. We can jump straight into making the G-code based off this, which we'll do in a second. But I'm gonna quickly open up one that I have made and show you what a tray could look like if you took the time to color the tray, put in your fillets, all your roundovers, everything like that, so you can see what a finished product would look like. You go, I don't have it colored, but this would give you an idea of what it's gonna look like if you went through, put on your roundovers, because we're gonna round it over naturally, and whatnot. And then I haven't actually got a fillet in there, but if you put in a 3 mil fillet on all of these, that's gonna give you a good indication of what it's gonna look like. But you do not require to do that for actually making it. You can simply use what we're going to use, the stock standard base shape. You're gonna go ahead and save the model in case it crashes, so we don't have to do that again. So you can save it whatever you like, wherever you like. I suggest making some form of orderly saving system here. I'm gonna create a new project and call it YouTube videos. Otherwise, I'm gonna get really confused really quickly. So we've been doing this in the design space. See up here where it says design, you can change your workspace to manufacture. This is where we go and make the G-code for the CNC, which effectively is the code that runs the machine. A few things you're gonna need to have set up is your machine within the software. We're not gonna do that today. A few things you need to have set up is the CNC machine that you're using in the software. You need to set that up. I've already done that for my machine, so we're not gonna be doing that today. But if you want more information like that, check out the playlist down below. It's all things CNC, run you through everything. And if you want more specific information, feel free to ask. More than happy to assist and impart some knowledge where I can. Okay, so first thing we're gonna do is we're gonna create a new setup. So the setup is effectively setting up the stock, selecting your machine. So we're gonna select our machine over here. I'll drag that over so you can see what I'm actually doing. So we're using a MakerStore Workpiece version 3 CNC. So logically, that's what I called it. Really creative. I could have called it my CNC because I only own one. And then see how the axis is set in the center? That's not how I operate my CNC. I always set mine up as the top left point because I have a workbench where I can butt everything into, and it's like a reference point. So it makes it really easy for me to set things up, but you can work with what you've got. So I'm gonna select my stock point as that corner. Then up the top, we're gonna go across to stock. So you've got a couple of options here. You can make it a fixed size, so measure the piece of timber you're using, or make it relative to the model you're using. So I am gonna use a fixed size because I know the timbers I'm using 320 by 320, 20 mil tall. So that's the size timber I'm working with. So if I plug that in, it's always going to be correct. But you could make it 20 mil bigger than the model you've made. Up to you how you want to work it. And then we're just going to hit OK. And that is our stock setup. So the stock, is represented by this like yellow shaded bit here, which shows you what is actually getting cut out. Now, we're going to go ahead and we are going to make our cuts. So we're going to use two bits here. We are going to use a cutting bit. I don't know if you can see that. Focus on the bit. We're going to use a cutting bit and then the bowl and tray bit, which we had right here. The one we're actually using in the CNC has a smaller shaft. I just ordered this one first and realized it doesn't fit in my machine, so I had to order another one. Live and learn. Make sure you buy bits that fit your machine. So we're going to have to go and add those bits in. So we want to go over to manage your tool library. And again, I'm going to drag that over so you can see what I'm doing. They are both Torquata bits. As you can see, I've added some of those bits in here, but we'll show you how to add a new bit. So we're going to go new tool. We're going to select the type of tool. So I am using, I'm so going to slice my fingers up doing this. Timbercon, can you make these easier? Easier to get out of the damn boxes. They're really well packaged. I'll be back. Need pliers. I'm back with pliers. Now, you're using pliers to get it out. Don't grab the blade. Hey. So, we are going to set up this bad boy here. A couple of ways you can do this. Depending on the bits you've bought, you may be able to find all of the information online. Some companies will actually have a CNC downloadable file that you can plug straight into Fusion. Other companies don't, but it's really easy to set them up. I'm going to use a really accurate wooden ruler because that's what I've got in here. I would highly suggest you use calipers to get as accurate as possible, because the reality is once you've set up this bit, if you buy the same bit every time, you don't have to set this up again, you just select the bit. So we're going to jump on Timbercon's website and we're going to do a little search for this bit. So you got the bit number there. Oops. Can you see that? Yeah, my gosh. So I can search for that bit. So we're just going to go SCD-064-Q-3-F. And here we have it here. So we're now going to look down here to find the one we're looking for. SCD-64Q. So this is this bad boy here. So we now have all of the information we need. We have the shank size, cutters, the cut direction, cut diameter, cut height, overall length. So we can go through and plug all of that information straight into Fusion. So we're gonna select, it's a flat end mill. As you can see there, the end is flat. So flat end mill. So we're gonna select that. Description. Logically, call it something so you know what it is called when you go to buy it again. Then you put in the vendor. I bought mine from Timbercon. Highly recommend you check them out if you haven't already. So I put that in the wrong field. Good thing I copied that. So I should have put in the top section this bit of information, which is straight copied and paste from the Timbercon website. And then I'm gonna go ahead and delete and rename to what my actual bit is. So mine is the 1/4 inch, so I'm getting rid of the 1/2 inch shank. It's triple boot. All that is still the same. And then we are gonna copy and paste the product link, because the reality is bits wear out over time. Sometimes you snap them. You wanna know at a quick reference, when you buy another one, how do you get it? I don't wanna have to think about this. I just wanna get it done. We're gonna go over to cutter. Plug in the information. We're working in millimeters. If you're in America, you will not be working in millimeters, but I am. I'm in Australia, so I'm working in millimeters. So other cool thing about this is Fusion basically does maths for you. So I'm not gonna go and work out and put in what a 1/4 inch is. I'm just gonna go equals 25.4 divided by 4. That will get me, so an inch is 25.4. If you work on 25, you're wrong, and it will, in reality, 0.4 millimeters doesn't matter. In the CNC world, 0.4 millimeters matters. Because if you make this 25 divided by 4, because a lot of people, particularly people that aren't in the woodworking realm, and a lot of beginners will go, oh, an inch is 25 millimeters. It's 25.4 millimeters. Issue with that is if you went 25 millimeters, say this bit cuts up and back 100 times through this here, okay? Up and back 100 times. If you're 0.4 millimeters out, all of a sudden you're 0.4 times 100. Let's do some maths. There's 40 millimeters. There's that much out by the time it's finished. 0.4 millimeters matters in the CNC world. Overall length is 52 millimeters. If I had have, read down a little bit, it said 6.35 millimeters on the Timcon website. Here, I'll show you. Right there. Just wanted to make it interesting for you guys. Keep you engaged. I'm trying here. Length below the shoulder. Other cool thing is that on the actual page in Fusion, it actually shows you what you're measuring. So if we've got the overall, that's the entire length of the bit. The shoulder length, the flute length, just the bit that cuts. So the cutting height in this case is 19 millimeters. So we'll put that in as 19 millimeters. Shoulder length is to the top edge of the cutter, which is 30 millimeters. Managed with my high-tech ruler here. And then under the shoulder, I'm gonna allow about 5 millimeters in there. This distance here will be about 5 millimeters, which will give me 17 millimeters inside my CNC, which is plenty. We're then gonna go across to cutting data. Cutting data is the biggest thing here. Now, I cannot stress this enough. If you take one thing away from this video, make it this next comment. Cutting information is vital. It changes depending on your machine, what timber you're using. So you're gonna need to play around. You're gonna need to tweak the settings. So basically, I have this bit entered in here 6 or 7 different times. I have this bit entered in here for a hardwood, for an MDF, for a acrylic. So that I go, that's the material I'm using. I've worked out by trial and error, and I say trial and error because I have snapped numerous bits. I have blunted numerous bits. So you just have to play around with your settings. It's always gonna change depending on what CNC you've got. So I'm not even gonna touch this. Because that is so different for everyone. All I'm gonna say is you're wanting to test it out. And then post-processor, you just give that a number and hit accept. And there we go, we've added this bit in. And then you do the same thing for your other bowl and tray bit. But I'm not gonna do that because I've shown you how to do it. You do the exact same thing. Follow the exact same process. Okay, so now we are gonna add our paths. So the path is effectively where the bit's gonna move. Now, one thing you want to keep in mind and consider what's gonna happen when you make your cuts. If we cut out the outside first, brilliant, that's gonna work really well until it starts to move as we're throwing in our big bit. So we wanna do pockets first, followed by our contours. Other thing you can consider doing is these bad boys are expensive. These ones are less expensive. You could carve out the bulk of the waste, so the majority of the waste, and then just tidy it up with this one here. But that all depends on what you're trying to achieve. If you want to save money on the bits, great way to do it. If you want to do it as efficiently as possible, using one of these might be the better option. So you just got to play around, work out what's best for you. Okay, so we are doing 2D carving. So we're going to click here. We want a 2D pocket. We're going to select our bits and pieces there that we are going to be carving in. So effectively, we have just selected these bad boys here. We're then going to go over here to the tool. We're going to select the appropriate tool. Okay, so we've gone ahead and selected the appropriate tool, which is this one here for our bowl and tray bit. If I show you the little bit here, you can see how the visual image, it's not working for me. The visual image reflects something similar to this one. The tool I've selected because I haven't added this specific bit in, doesn't have as wide of a flat bottom, so I would have to amend that if I was actually going to use this exact bit, but it doesn't fit in my machine, so I'm not adding it because I'll use this for a handheld router. So I've selected that. All of the feeds and if I can get some words out, all of the feeds and speeds automatically preset based on the tool you used. If you wanted to tweak these for a specific project, you can do that here, still keeping your default parameters for your actual bit. So we've already selected what we're going to be cutting. Heights. So we want to go to the selected contour as the bottom height, which is where we're cutting there. So that is all preset based on your machine and how you've set your model up. Okay, this is where things get interesting. So what we're wanting to do is add multiple passes because I don't want to burn out my machine. I've got a hobbyist machine. So we're gonna make the maximum roughing depth 3 millimeters. We're gonna use even step downs, and we're gonna use a finishing pass down the bottom. We're gonna do 2 finishing passes down the bottom, and we're gonna slow the finishing pass down, and we're not gonna leave any stock. We're actually gonna do 1 finishing pass there, and then linking again, all preset based on your setup of your machine. So we're gonna hit OK there. We're gonna see, this is a really good example here. See here, we've got the natural fillet. We didn't design that in, we didn't draw that in, but we've got that there because that's what the bit's naturally gonna do. That's why you don't have to spend your time in the software, wasting your time. Time is valuable. Understand this is everyone's hobby, or I would say 90% of the people that watch this channel's hobby. So you don't wanna waste your time playing around in the software if you don't need to. And then what we're gonna do here is we are gonna go up to, or right click here, and we're gonna go simulate. Just to double check we've got everything correct. So we're gonna hit the play, try to slow it down.
1 eternity later.
Okay, now we're getting somewhere. So now you can see here, it is actually gonna map out the exact path it is gonna take. So what I would suggest is let that run through, make sure you're happy with everything, because it's a lot easier to fix an error on a computer than it is on timber. If you realize after the fact that you've selected the wrong section and you've cut it out, you've wasted your timber. If you don't know where your clamps or your hold downs are gonna be, and it hits clamp or hold down, you've wasted a clamp, you've wasted time, you've wasted timber. So you wanna take the time to run the simulation and make sure it is on point with what you're trying to achieve. But I'm not gonna waste your time watching this, so we're gonna skip over this. So now we've got our pocketings done. So now we're gonna go ahead and we're gonna add a 2D contour, is the word I'm looking for. So this bit, if we were to use a contour for, I can't even see my bit. If we were to use this bit for the contour cut, it's effectively gonna come around the bottom and we're gonna be left with that round. So that's why we're swapping out to our straight cutter. So we're gonna go select, over to Torcata. We added this bad boy here, which was the 3 flute cutter. We're gonna select the bottom edge. The reason we're selecting the bottom edge is we wanna cut down to the bottom. Now, there's a few ways you can do this next step. So tabs are effectively little bits of timber that will hold your machine in place. So if you see here, let's hover over that and it'll come up. So you can see on there, there's 4 tabs there. That will hold, because effectively you're gonna be clamping the outside perimeter. So this bad boy was originally a square. So you're gonna clamp these sections down to hold it in place. So the tabs will keep this from moving as it's being cut out. A couple of ways you can do it. You can get rid of the tabs and you can double-sided tape this down onto your bench. Other options is you can have a vacuum table, like I'm gonna show you how to build in a couple of upcoming videos. So if you wanna see that, hit that subscribe button. Or alternatively, you can leave a thin bit of timber around the outside the entire way around. Because reality is, you're gonna have to flush trim this anyway. I give mine a round over. So what I do is I leave so I don't use the tabs, I leave a 1 millimeter thick bit of timber around, so that when I do my round over, it takes care of that, and I just bang my router in. You like my sound effects? And it gives a round over, and it takes care of that 1 millimeter. So much quicker and efficient for me and my setup, but you do what works for you. So tabs, in my case, I'm not gonna put tabs in there. I'm gonna go across here to heights, and instead of being 0 millimeter offset from the bottom edge, I'm gonna make that -1. So what that will do is that will bring the offset up 1 millimeter, leaving a thin amount around the outside. Again, we're gonna do multiple depths. With this bit, I'm probably gonna go 4 millimeter maximum depth. Again, this is gonna be different for everyone's CNC. Do what works for you. You can increase the speed of the machine and do shallower passes, or you can do deeper passes and slow the machine down. It all depends on your particular machine. So we're gonna hit OK, bugger that up. I should have gone a 1 millimeter offset. So we're gonna go here, edit. We're gonna go over to the height. So we wanna bring it up 1 millimeter, not -1 down. Yep, laugh at me later. And now you can see that it's gonna cut down, but it doesn't cut all the way through. So that allows me to use my vacuum clamp, suck it down to the table, and then I can use my round over to take care of that. Okay, so we've got our G-code. Again, I would run a simulation, just check that I'm happy with everything there. It all looks very nice from up top. So I would be happy with that. So now what we need to do is export it. I don't pay for Fusion, I use the free version, so I have to export them in 2 separate files. So one I would call, I'll show you. So we're gonna right click, we're gonna go down here and we are gonna go post-process. Again, I'll drag it on so you can see this. That's my machine, that's my post-process. I'm gonna call this test tray. And then what I do is I then tell myself what bit I'm using. So I'm using the torcata, yep, that is spelled correct, bowl and tray for my first pass. So I'm gonna hit OK. And then on the second pass, we're gonna go here, we are gonna go, whoops, post-processing again. This one we're gonna go, so test CNC tray. And again, we're using the torcata SCD 064 Q3F. So then when I get out to my shed, because this is not in my shed, this is not in my workshop. I don't know if you realize this is an office space. So when we go out to the shed, I don't have to go, oh, what was what? I'm not getting confused. I just go, okay, pick up that bit, pick up this bit, all labeled. Everything is crystal clean when I throw it into my software to run my CNC. So then we would hit post and bang, we now have our G-code to throw into our machine, ready to rock and roll. So you've just seen the complicated way of batching out one of these trays. You can make these as complicated or as simple as you like. So there are hundreds of different ways you can make this, probably thousands, depending on what you want to do. The easy way, now I'll show you the easy way. So people like myself love to make stuff. And I love to make files that allow people to do things a lot more easily. So if you jump down into the description below, I actually sell a file pack of CNC trays. And basically it does all of the design work for you. You just bring it in and it's done. So I'll show you. So this is a pack that you can buy from me. I'll leave it linked in the description below. So basically you get all of the trays, I think there's about 15 or so, that you can pull straight into Fusion and get working with. I'm gonna leave a discount code below as well, probably for 30 days after this one goes live, but check the description pin comment and there should be a discount code there for you. But what I'll do is we will go over here and we'll go File, New Design. Okay, so this is what you get when you purchase the CNC pack. So you get all of these downloadable files. So let's just go and pick this random one here. And it basically gives you the pattern, gives you all of the files here in various different formats. So all you do is go over to Fusion, you're gonna go insert up here. We're gonna insert a DXF file. We're gonna pop that on the bottom edge. We're gonna open up our file. So I've then gone and selected my file and bang, job done. There's your design there and you can go straight into extruding it just like we did before. And you don't have to take the time to make measurements, work out what you want to do. And you got 15, I actually think there's 20 different styles in there. So if you want a quick and easy way of doing it, check that out, help support the channel. Or you can go through the first method and design your own, whatever suits you guys. I hope this tutorial has helped you gain an insight into how to design it. We're not actually gonna batch these out yet. If you jump over to the TimberCon YouTube channel, they are gonna have a video of how I actually manufactured from start to finish these products here. So I highly recommend you check those out. Again, link in the description. If you wanna see more content like this, if you want to learn more about CNCing or just woodworking and DIY in general, make sure you subscribed. And as always, happy building. Cheers, guys.